All right, so today we're going to finish up the slides that we started on Wednesday. I have one example of using a stack and a queue. The queue is kind of a little hidden in this one, but at least a stack. Showing you how to use a stack to accomplish a specific goal. So there's a specific application where a stack comes in handy. We're going to go through this. There's going to be time after this at the end of lecture. And for that, I've decided I'm going to take homework questions. So if you have homework questions, get them ready, get them in chat. We'll start some open-ended discussion a little earlier, and I might keep it on YouTube. I might keep the annotation out. Well, probably not, because by the time people on YouTube see it, the homework will be over, or at least the checkpoint for it. So let's get through this example. Let's talk about this first. Yeah, animate AI, LT5 hints, LOL. Yeah, I mean, yes, that's basically what I'm saying is I'm willing to give hints today, but you can't just be like LT5 hints. Goodness, that's driving me nuts. I know you're joking in that one with the LOL, but LT7 hint. That one I think is serious. Damn it, repetition. All right, so let's talk about this. One application of a stack. To talk about this, we're going to need a little bit of background. First of all, this is infix expression. This is algebra in the way that you're used to seeing it. The way we usually see algebra is infix notation, which means that the expressions are placed between the two operands. So 12 minus 4, the operator is between the operands. We're used to this. This is, how we learn. This is how we learn mathematics. This is how we learn algebra, or arithmetic rather. And this has one problem: is the order of operations is not immediately clear. So whenever we need to override our order of operations, we're going to add parentheses. Otherwise, it's division and multiplication before addition and subtraction. Exponentiation comes before those two, etc. So we have these order of operations. You learned PEMDAS to get the order of operations right. And in general, parentheses override the order of operations. So there's quite a few rules here involved to be able to get the order of the evaluation correct. It's like you're hearing me through a World War II communication device. Man, I don't know. I don't know what I did to this thing. I'm assuming this isn't any better. Just this thing. Yeah, I don't think that's going to help. I think we're just going to have to live with that, unfortunately. As long as you can understand me still, if it just sounds a bit weird. It was fixed, but is it fixed right now? Is it fine? Better? Oh, fantastic. Bit better? Not right now. Still the same. Maybe it was this setting. Let me do this then. Maybe that got spun. Better but not fixed. Sounds amplified now. Maybe this. Wiggle it a little more. Yeah, I'll just spin the settings until it sounds good. I feel like I crawled into your head. I might just have to restart this whole machine. Sounds good? Pretty good now? Yeah, it's good? Alright. So maybe I did just have the gain turned up. Perfect. Fantastic. I'm glad we took that time to fix that, so we don't have some bad audio on the VOD. Alright, so this is infix expression. You're used to this. When we want to evaluate this, we're going to use PEMDAS. Start with the parentheses. Evaluate this. This evaluates to 8. Go inside the other parentheses, and then evaluate the division before this addition. So we skip over the addition, compute the division, then the multiplication, then the addition, then the final subtraction. You're used to this. You can't remember what Jesse sounds like before. You know what this is all about. Super review. Don't really need to talk about it. What I want to compare that to is something called postfix expressions or postfix notation. If PEMDAS is stressing you out, Roblox lover, oh my goodness. I don't know if I can help you with that one. adding PEMDAS to your resume. I'm sure in, I'm sure recruiters will be really impressed that you can do arithmetic. I would be shocked if you can't. I would be concerned. So, oh shoot, I forgot to add LT2 to the slides. Yeah, you're right, Priest. LT2 is today. Let me do it in the doc, just so it's on the VOD. So the lecture task for today is LT2, path to direction. I'll have to add it to the slides after the fact. Path to direction. Given a path as a linked list of grid locations, which is a class in the repo, and a lot of these you have to look through the repo to see what these classes are, to see how they're represented. Yeah, what's up, Eric Cartman? And the grid location is going to have an XY location as ints. You have a linked list of player locations, which have locations as doubles. And you want to find out, with this player navigating this path of grid locations, which direction should they move to follow this path. So a few things here. First, you have to find the player's location, given this linked list, to get their location as doubles, to get their exact location. And then look at the linked list to figure out exactly where they're supposed to move. If this linked list, you can assume that the player is on the first tile of the linked list, the first grid location of that linked list. And when they move, they're either going to move to the center of that first tile, the tile that they're on, if the list has length 1. If the list has length greater than 1, they're going to move to the next location on that path. So they're going to move to the center of the second tile in the path. And you need their location as a double, so you can compute the direction that they're going to move by taking the center of the target tile minus the location of the player. And that'll give you the location that they need to move. For testing this, you have to make sure that any vector in the correct direction is going to be accepted. There's a normal 2D method inside the vector class, which is going to remove the magnitude, convert the vector into a magnitude 1 vector. So if you call normal 2D on both of your vectors, just like we sorted lists, just like we've done 2 lowercase, other things like this, if you normalize both vectors and then check using your epsilons if they're the same-ish, then you can compare 2 vector directions even though the magnitudes were different. You're going to call normal 2D, normalize them, and then compare them. I think that's all I need to say about this one. Yeah, I think that's all I need to say. Yeah, I'll get that in the slides after the fact. I'll create this slide. Oh, but I don't have new slides. I'll have to create like a slide deck with just that. I don't know. I'll think about it later. So let's talk about postfix expression. This is much different than the arithmetic that you've seen. Shouldn't the tile to the right of the origin be... Oh, I said left instead of right. Let me fix that too. And I feel like I'm all over the place. Yeah, the tile to the left of the origin wouldn't even be on the map. Son of a bitch. Oh, I think Rin's got me covered. Thank you. Can't even find my mouse. Okay, we got this. Promise we'll talk about... Thanks, Nicholas. I promise we'll talk about postfix. Okay, so postfix expressions. This is the same expression that we saw on the previous slide. It's this same exact expression, except instead of written in infix notation, it's written in postfix notation, which means the operator comes after the 2 operands. So now the operator comes after the 2 operands, but we're doing the same arithmetic as we did before. And this is a 12, just pointing this out, this is a 12, not a 1 and a 2. And then space, and then a 4, an 8, 9, 3, and 2, just to make sure that we're reading it correctly. So This is kind of nice because we don't have to worry about order of operations or parentheses, which makes it a lot easier to write an algorithm for a computer to compute this expression. A computer can compute this. We can write our code. You can write a method to do this without much issue. Where if you're writing in an expression evaluator, and this used to be an assignment, by the way, evaluate infix expressions. If you're writing an evaluator for infix expressions, that code gets a little messy. You have to look for parentheses, pull out the expression, the sub expression inside the parentheses, then do your order of operations. There's a lot of conditionals. There's a lot of stuff going on there. You have to do quite a bit of work to parse it. If you have a postfix expression, no big deal at all to write a code to do that, and we'll talk about how to evaluate one of these on the next slide. And one disadvantage is this is harder to read. If you weren't trained, I don't even think this is much harder to read. I mean, I do because, I don't know, I can't really read this. But objectively, I don't think it's harder to read. It's just that we were all trained on infix. Like, we've been trained how to read this. If everybody was trained how to read postfix, I don't even think this would be harder for humans to read. So it's harder for humans to read without practice just because we don't have any practice with postfix expressions. Well, this just isn't the way we usually see expressions. So to evaluate one of these things, that's why. So to evaluate one of these expressions written in postfix notation, what we do is scan the elements here. Whenever we find an operator, we're going to look at the two previous values, and those are our operands, and we're going to evaluate that. So we have a subtraction. We're going to look at the previous two things, 12 minus 4, evaluate that, and replace those values with whatever that evaluated to. Then we continue scanning until we find another operator. Previous two values, those are the operands. 9 divided by 3, that's 3. Find another operator, multiplication, 3 times 2 is 6. We find an addition, 8 plus 6 is 14. And then we find another operator, 8 minus 14 is 6, negative 6. And we get the same evaluation. We actually evaluate the same exact operators in the same exact order as we did with PEMDAS. We did the same exact evaluations, the same exact math, except it was written in postfix notation instead of prefix notation. So a lot of nice advantages. Like, you can write an algorithm to do this. You can have a loop that iterates over a list of operators. You can do this pretty easily. Writing a method to evaluate this, quite a bit harder. So what if we had to evaluate an infix expression? Again, this used to be an assignment that I would throw at the class. Not this semester, though. Is I would give you an infix expression and say, evaluate this. And I think one of the simplest ways to do this is to first convert this into a postfix expression and then evaluate the postfix expression. So do two passes on this. Convert this to postfix, which is what we're going to talk about with the shunting yard algorithm, and then evaluate the postfix, which is much simpler than evaluating this directly. So for this, we're going to talk about the shunting yard algorithm, which is going to convert infix expressions into postfix expressions. To do this, this is the entire algorithm. This is the definition of the algorithm. We're going to read this expression from left to right. And every character we read, or every symbol we read, every token, I guess technically, every token we read, we're going to make a decision based on what we read, and we're going to use a stack. We're talking about stacks. We're talking about linked lists. This is an application of a stack. So whenever we read something, we're going to ask ourselves a question. If it's an operand, we're just going to copy it to the output directly. So when we reach this 12, we just copy it to the output. And the output, you can think of this as a queue. This is where I said queue. It's kind of, it doesn't have to be a queue, but it's kind of a queue. We're kind of using a stack and a queue. But we can add that 12 directly to it. Whenever we read an open parenthesis, we're going to push it to the stack that we're going to use. And we're going to leave that on the stack until we read a closed parenthesis. If we read a closed parenthesis, we're going to evaluate everything on the stack until we pop an open parenthesis. And whenever we find an operator, we're going to check the top of the stack and then copy things from the top of the stack over to the output until the top of the stack is in either empty or an open paren, or the most important one to check, an operator with lower precedence. So like if we're looking at division and addition is on the top of the stack, then we're going to push the division onto the stack. Like, how do you know which goes which? PEMDAS. So we're going to walk through this whole example too. But it's PEMDAS. Like, addition and subtraction have to be evaluated later than multiplication and division. And the parentheses are handled specially. All right, let's look at, okay, so that's kind of a mess. It's a really short explanation of what the algorithm is. So let's walk through this step by step and see how each case occurs. So we're going to have a stack that we're building, and we're going to have the output that we're constructing. We're going to use the stack to help us build the output, and we're going to follow these rules each time we read one of these things. So push operators and parentheses onto the stack. Open paren, we always just push to the stack. Push to the stack. Operands, we always just copy to the output. No decision to be made. Copy 12 to the output. And now we find our first operator. Either the top of the stack is empty. I don't think I do have it. The top of the stack is empty, or the top of the stack is an open paren. Then we're going to push this onto the stack as long as the top of the stack is not an operator which has equal to or greater precedence, where greater precedence means it should be evaluated earlier. So if like multiplication or division was on the top of the stack, we would copy it to the output and then push subtraction onto the stack. We don't have that. We just have an open paren, which is effectively an empty stack. So we're going to push the subtraction onto the stack. Operand, we copy over. A closed paren, we're going to copy whatever's on the stack over to the output until we find an open paren. So we pop subtraction, copy that over to the output, and then all the parentheses disappear. We're done with that set of parentheses. And you can see we do have 12 minus 4, which was the beginning of the first term in our expression here. Subtraction, it's an empty stack, so we just push it to the stack. Open paren, we always just push to the stack. Operator, we always just copy to the output. Addition, open paren on top of the stack is effectively an empty stack, so we push. 9, operator, operand, we always push to the output. We always just copy to the output. And now we have our first decision. We have division that we're processing, and addition is on the top of the stack. So we're going to pop from the top of the stack until the top of the stack has a lower precedence than the operator that we're evaluating. Well, that's already the case. Addition needs to be evaluated after division, so we're going to push division onto the stack. You can see this is where we're getting our order of operation. We want to make sure that division is evaluated before that addition, and this is how we make that decision. Well, should this be evaluated before this? Well, no, so we're going to push this to the stack on top of the addition. That means when we're popping off of this stack, we have to pop the division before that addition. So the division will be copied to the output before the addition. So we're going to just push division onto the stack. Operand, copy it. Operator, we're going to pop from the top of the stack until the top of the stack has a lower precedence than what we're looking at. Multiplication and division are tied, so we're going to pop the stack. This is not strictly less than this in order of operations. So we copy the division over. This does have to be evaluated after this. It has lower precedence. So now we push multiplication onto the stack. Operand, copy it over. Close paren, we're just going to just pop out all these off the stack, copy them over to the output. Multiplication, addition gets deleted. We're at the end of the input. So everything else that's left on the stack, copy over. Now, if you didn't follow all the details of that, that's fine. I'm not going to quiz you on the specific details of shunting yard. But suffice to know that this is an application where we can use a stack. So if you're asked for, hey, what's an application where you could use a stack, you should be like, ooh, shunting yard. That postfix notation was weird stuff, but shunting yard helped us with it. And we've successfully gone from that infix notation to postfix notation. And then we could evaluate the postfix notation. Scan for operators, 12 minus 4, 8. 9 divided by 3, 3. 3 times 2, 6. And keep going through until it's evaluated. Lecture task 1, yeah, because these are Wednesday slides. So I'll create a slide deck with just one slide for lecture task 2. It'll just be a copy of what's in the document, but just for completeness. It would bug me if it's not on the schedule. If it's like the one lecture task that doesn't have a slide for it, that would just bug me. And I think it would bug some of you as well. All right, so that's the wrap-up of slides. That's the end of linked list stack queue. So let's open this thing up. I'll take questions from chat. I saw a question earlier. One of you couldn't wait. I'll start with that one. And then whatever you want to ask. So I'd say good candidates are, of course, the assignment that where we have a checkpoint today. That assignment, if you haven't finished that. A lot of you have finished that. And look, I'm willing to bet that those of you who show up to lectures, a higher percentage of you have that done than the students who are not showing up to lectures. So if you don't want to talk about the project, we can talk about enemy AI. We can talk about project contribution, or we can talk about review of linked lists if something about linked lists doesn't quite make sense. Or if you want demos of linked lists, that would be cool too. I won't prioritize anything. I'll just take questions as they come. Because I don't really know. Maybe there are a lot of students who came here for Project 3 hints. I don't know. Question for Project 3 LT5. I'm a bit confused by the concept of overall rating for a song that we'll be working with. A song should have a list of song ratings. The store rating int and energy int, yeah. So I don't know which rating to work with. If I ever just say rating, I mean rating. I guess I don't have much to add there. If I just say rating, I realize I reused that word a few times. But if I say rating, I mean the rating. And if I say energy rating, I mean the energy rating. So rating would be that. So rating would be the literal rating. So when I say overall rating of a song, I mean the Bayesian. What was my wording on that? Overall rating. We will combine the overall rating of the song with the user. By overall rating here, I mean the Bayesian average of the ratings. Would be the name of those values on the stack. Yeah, whatever you want to name. If you were writing that program, I don't know, name them whatever you want. The values on the stack wouldn't have names, but the stack itself would have a variable name. LT2 doesn't seem to be related to today's content. Truth. True. LT1, 2, and 3 are all related to really Monday's content. After Monday, you could do all LT1 through 3. Are we getting an extension for LO3? Learning? Yes. Yeah. And it's kind of a weird thing because I realize, because I've been doing this all semester, but if you've always finished the project, the first 2 projects, if you finish them before the checkpoint, you wouldn't have a reason to know how the recovery plans work. But if you don't finish the homework by the checkpoint, you get a recovery plan, and you're almost guaranteed to get at least to get 1 extension in that recovery plan. You'll get more time to work on the project. And I'll send emails out Um, Optimistically, I'll get that done this weekend. I will prioritize the homework 4 grader first, so you won't see any recovery plans until the homework 4 grader is complete, both application objectives and everything. Once that's done, I'll start working on recovery plans for LO3. So more realistically, probably Tuesday you'll get an email with your recovery plan details. But don't do anything rash like resign the course just because you didn't finish the project, the genetic algorithm project, on time. You will get an extension. You are guaranteed to get one extension as long as you've shown any effort. If you've literally made 0 submissions to Autolab, you might not get that. That's the only way you might not get the first extension, or you might get a lesser extension. But you will have more time to finish the lecture tasks in Learning Objective 3 as part of your recovery plan. Because it's do or die on those. You finish all the LTs or you fail the course. So I'm going to be reasonable about. That's why it's called a checkpoint and not a deadline. That's not the end of it. That just means you go on a recovery plan, and you have more makeup opportunities. Same for the interview and quiz. If after the first 2 opportunities you still haven't finished both of them, your recovery plan is going to include at least one more opportunity to take the interview and quiz with me, so I can see if maybe you know your stuff, but you had some health things or some family issues come up. Like, I don't want that to cause you to fail the course. So I want to give you at least one more chance in the recovery plan. Come here often, but you watch the VODs. And there are a lot of people. The numbers of viewers on the VODs are pretty high for this. But the thing is, I guess with the extension, this lecture will still be valid after the checkpoint. But when I was saying that, I was like, well, people who watch the VODs aren't going to get this in time for the checkpoint. But you know what? With the extensions, I guess it will be valid still. But that's the context of what I was saying. That is, the people who watch the VODs might not see this in time by midnight tonight. But since you'll have more time. And by the way, since you can count on that extension, don't stop at midnight. That's why the last day to submit is tomorrow night. And I'll update that if I don't have recovery plans out tomorrow, which I probably won't. I'll extend that deadline, that last day to submit, and I'll keep extending that until I decide when the extension date is going to be, and then I'll set the last day to submit to the extension date. As a reward, can I give you the answer to AO2? Jeez, a lot of things I would have said yes to, but you're going all the way, you're going for the whole shot. Give us AO2? Jeez. It would take a while. It would take a lecture just to explain my solution to AO2. Maybe not a whole lecture, but AO2 is tough. It's meant to be... The AO2s in general are meant to be where you earn your A. Actually, can I even say that? The project for AO2 I don't think is very difficult. It might be one of the easier AOs. So that's the intent, though, is that AO2 is where you not even earn your A, but that's where you show off. Because you don't need any AO2s to earn an A. But that's where you show off is the AO2s. If you really want a nice challenge, AO2's there for you. You're here for enemy. Hey, congrats, Priest. Take about AO1. I like genetic algorithms. Love a demo with the linked list. And what would you want to see demoed? So we have... did the live coding thing yesterday, or Wednesday rather. Let me catch up to chat a little bit and see if we have some more specific requests. Earn a comment, but reading about and understanding the idea of genetic algorithm is super cool. Nice, it's such a cool concept. I agree. Yeah, I think that AO1 is I think that's part of what makes it fun. First of all, I don't have any strict requirements, like you have to do crossovers and you have to do crossovers like this. I left it really open-ended. As long as you produce an algorithm that spits out an optimized solution, you're going to get the credit. So you can watch the videos that I link and learn how a genetic algorithm works, decide how you want to design one. It really lets you flex your design muscles. You have access to the ID of the player. True. Oh, I'm just reading my own documentation. Where's your actual question? Here's the constructor. It doesn't mean the player in the linked list. It means whenever I say this player, I mean like this dot player ID. I mean that player. So I use this in the document, in the homework document, to mean like as in this, the keyword in your code. Which I realize is a little confusing. I do want to take another pass at the doc and clarify everything to make sure it makes a little more sense. But that's how I use the keyword this in English. I use it as if it were the keyword this in your program. That was 3 questions? Oh my goodness. So if the ID in the constructor parameter is an AI or a human player, it doesn't matter. AI or human, they're all treated as players in the code. Doesn't matter. What is L2 Euclidean distance? I saw these questions earlier. Well, you asked this somewhere where I didn't have time to answer. Was that an email or maybe it was Piazza? L2 Euclidean distance, that's the square root of the sum of the sum of the squares of the differences. It's like x, other x minus x, square it, other y minus y, square that, and then take the square root of the sum of those. You've done that. I guarantee you've done that many, many times. Maybe you didn't call it Euclidean distance or L2 distance, but I guarantee you've done that. What is that called? I thought it was always called Euclidean distance. Or think of a right triangle. Finding the hypotenuse of a right triangle is the same math. Any hints? Seriously, guys, this is driving me nuts. You can't just ask for hints. Give me a specific question. I'll probably answer it with a hint. Duplicate song in a playlist. Actually, this one I might be able to get a hint. I guess that's specific enough. You didn't just say hint on LT6. Duplicate song in a playlist. You have a way of removing duplicates. We saw that when I did anagrams. And in that Wednesday lecture, the second lecture of functional programming. You saw a way to remove duplicates. So if you remove duplicates, create a second list with the duplicates removed, and compare the length of that list to the length of the original list. If it's less, you know you had a duplicate. How do I use recursion in LT4? I'm not sure how to answer that one. So you'll want to start. So first of all, if you didn't use recursion in LT3, do that first for practice. Recursion in LT4, you'll want to create a helper method. You won't really be able to do it with the method that I give you. Like that one can't really be recursive because it doesn't take the right parameters that you're going to want, and it might not return the right return type that you'll want. So what you do is create a helper method, a second method that's going to be your recursive method, and then from the original method, just call the second one. That helps you get more flexibility in setting up the recursion. And then think about what your base case is. You're probably going to want to process one line at a time. So your recursive step is process a line, remove that line from the list, and then make a recursive call. Your base case is probably no lines left to read. Return an empty list because there's no data here. And the rest I'll let you figure out. I'll let you resolve. The hint I have been given enough students, let's get it in a YouTube video just for completeness, is I think it helps to use a map of strings to songs where the strings are YouTube IDs and the songs are just songs. I'll let you think about how that helps you. But if you create a map instead of a list, and then when you return a map with all the songs, take the values of that map, turn it into a list, and then return it. How do you, let me, I'm behind enough, let me get chat on stream here. How do you optimize GA properly? I can't seem to pass test 4. What I find to be the most important part of optimizing that thing is, oh my goodness, I'm not trying to build suspense, I just can't think of it. Mutations. The mutations, make sure your mutations are looking really good. If your mutations are sharp, your genetic algorithm is going to be real nice. I think mutations are more important than crossovers. Your mutation, make sure you're wiggling by just a little amount. The analogy I like to give is think about throwing a dart at a dartboard and getting close to the bullseye. What mutations are doing is kind of wiggling that dart around and searching that area close to where your dart landed and trying to get even closer to the bullseye with your next throw. A common mistake I've been seeing in office hours is with mutations, you're mutating a ridiculous amount. Like you're throwing a dart at a dartboard, you get close to the bullseye, and then you take that dart and say, okay, let me put it somewhere else on this dartboard in this huge area. You want to just do a very small wiggle and search that immediate area. You don't want to be searching, potentially getting mutations that are not even on the dartboard. That doesn't help us at all. You might as well just be adding more random animals, random genes. You're not gonna narrow in on the solution that way. For LT3, do we just do the math and return the head? So the rest of the nodes in the linked list, the head. Oh, LT3 in the homework 4. LT3, do we do the math and return the head? So the rest of the nodes that is the linked list to the head will be the return, right? Yeah, you just return the head of the linked list. And since the next value, oh my goodness, how do I say it? The head of the list has a next, and that next is going to refer to the second element in the linked list, and so on and so forth. So in your testing and in my testing, we're going to traverse the entire linked list and make sure all the values are there until we read a next of null, and we're going to do all that. So you just return a reference to the head of the list. A reference to the head of a linked list effectively is the linked list. Same is true with arrays. If you have a reference to the first element of an array, that effectively is the array. That'll come into play strong in 220. In C, an array in C is just a reference, or rather a pointer, to the first element of that array. And then you use that to access the rest of the values based on your arithmetic on the memory addresses like we saw. So yes, you just return a reference to the head of the list. So just keep grinding project 3. Yep, keep grinding project 3. Don't stop until you're done. You'll get at minimum, I won't give an extension that's less than 1 week. So keep grinding at it, keep working at it, get those lecture tasks done so you can finish the course. Can we have an extension for AOs on LO3? No. No extensions ever on AOs. At least this semester. I was just chatting with a student about that via email. Maybe next semester I might consider having some way to get extensions on AOs, but this semester the policy is no extension on AOs. To compensate for that, I gave you twice as many opportunities for AOs than you need to earn an A. There are 12 opportunities, and you only need 6 for an A. If you miss a deadline, is that really the end of the world? You just do a different AO and still walk away with an A. I'm just not going to feel bad for you on that. So for LO4, how long is the extension? It can't really go longer than that. With LO4, I was just thinking about this today. Since LO4, if we look at the timeline here, I think I will let the extension spill into finals week because I have to because it's the last day of class is the checkpoint. So you'll at least get finals week to work on it. Final grades aren't due until a week after that, so I do have the potential to give extensions past May 14th. So if you still need that, we have that time available to us. Hopefully not very many of you need that time. Hopefully you just get the thing done. But yeah, LO4, I realize that we're kind of up against it there in terms of extensions. Just get it done before the checkpoint is the standard answer. But yeah, there's a point where I can't give any more extensions because I have to submit final grades. But that's usually a week. They give us a week after finals to grade the final exams before final grades are due. How do you know if you got credit for the project contribution or not? Will it show on the UB Learns after? Oh my goodness, I don't even understand this question. I haven't used UB Learns for literally anything in this course. No, I will not post it on UB Learns. That's wild. Um, I'll probably email you. I'll probably email you your results and also post it on Autolab. But nobody's filled out the form yet. Why too? You made a great contribution, by the way. You got to fill out the form though, because you know what? I don't know who you are. I don't know. Possibly we met, and maybe I should. I don't know if you've ID'd yourself to me though. Like I don't know who you are. Regardless, who do I give that credit to? Unless you fill out the form, let me know your UBIT, and then I can assign the credit to you. But you have a great thing. I'm ready to give you the points, but you got to fill out the form, man. You got to fill out the form, bro. Zero students have filled that out, unless somebody just did during this lecture. We get a test case for LT2. I mean, not right now. Next week's lab is going to be all about that, though. Next week's lab is where you're gonna get test cases and generate test cases for all the lecture tasks. Need help with LT5 returning a function? I don't get it. Take a look at my so we did an example in class, but I also have examples right in the right next to where you're gonna write that. This is a method that returns a function. I give you one for song and one for playlist. So I have examples right there, intentionally put there so you have something to reference that does exactly that. In lecture, we did the sorting by distance to a reference point. That was a method that returned a function as well. So we talked about it in lecture. Go back to that lecture if you want to see about returning functions. Need help with LT5 in general. I'm a bit confused by the concept. I'm trying. I recommend reading reading AO1. So LT5 and LT6 are setting up for AO1. So if you read AO1, it might help you understand where you're going with LT5 and LT6. When is second chance quiz interview grade up? You won't see it until at least the grader is finished for Project 4. Then I'm going to go through all those and generate the recovery plans. At the latest, Tuesday. Repetition with that illegal. Yeah, that AO was so bad that I'm actually going to have to look through anyone who completes AO2 and make sure nobody else did that. That was bad. You completely bypassed all of genetic algorithm and all of, I'm blanking, neural networks, which completely defeats the purpose. But yeah, I realize how cheesable it is. Yeah, anyone who does that, you're not getting your credit. I will take away that AO. It's a big flex. Those were tough. And getting both of them on the current project, on Project 3, that's tough too. Getting both of them on Project 4 isn't going to be quite as hard. How far behind am I? 15 minutes? Oh yeah, let's talk about 191. Let's go. Distance formula, not Euclidean. Yeah, but yeah, I mean that bothers me, but sure. That's what it's called in high school, distance formula. I guess, you know what, I guess. Yeah, I guess. I guess it is a general distance formula, isn't it? Only in Euclidean space, though. Which means that the axes are all perpendicular to each other. That's what Euclidean space means. So it's Euclidean distance. Like the distance formula, that's not going to be the distance in polar coordinates or any like nonlinear space. But I guess I don't know. Maybe those are. Yeah, I get it. Yeah, distance formula. I guess most most of the time when we talk about anything, we're going to be talking about a Euclidean space. So we can just say, you know what, that's distance in normal world. um, or once you start talking about, um, quantum stuff, like down in the quantum realm, if I can use that term, that's not what distance is. Oh, the Pythagorean theorem? No, that's for solving quadratic equations, isn't it? Can we extend AO deadlines? Why is everyone asking that? No, we can't. I've never given an AO extension this semester. I guess technically that on the last deadline because Autolab wasn't given feedback. And with the AOs, I mean, if you put all the pieces together and you're really paying attention to everything, you know that you can do the AOs until probably Sunday. If you really are paying attention to everything I say. Distance formula, just more specifically known as Euclidean formula, though. Yeah, I'll buy that. Because in high school, they probably don't want to start throwing the word Euclidean around too much. They don't want to overwhelm your little high school brains. So they probably just say distance formula to keep it simple. It's not like you're doing polar coordinates and imaginary numbers and stuff. And actually, you do imaginary numbers. At least I did when I was in high school. They probably still do. For LT1, we're under the assumption that the location and ID in the constructor ID is in the linked list. Yes. I believe I made that explicit, right? You can assume it's not empty or null. You can assume the input ID is one of the player locations. Actually, I think I just added that right before lecture. I think that just came into existence. So if you read the doc before, it wasn't there. I want to use locate. So you have to create a new instance. So I'll tell a little bit of a story on this one. You import AI player. You have to create a new instance of an AI player. So you have an object of type AI player, and then you can call locate player through that object. This is because that method is in the AI player class. All the methods are in the AI player class, which means you need objects of that type to be able to use those methods. On project 3, I created a song class and a song object. So when we write a method that doesn't need any of the state variables, I put that in the song object so we could do song dot and then the method name. And then I got a whole bunch of questions like, oh my god, there's an object and a class. What do I do? My whole world is crushing and I don't know what to do. So to avoid that, I just put everything in the AI player class, and now I'm going to be getting this question. Well, now how do I call these methods? Well, you need an object of that type. I feel like I don't have a win here. Like next semester, I just got to pick one or the other and just shove it down your throats and say, this is the way it is. This is how you're doing it. There can be an object and a class of the same name, and it's cool. I'm probably going to choose that one and go that way. Give away the whole solution on LT4, was it? I gave a pretty good hint on that one. How to use Bayesian average in LT5? I mean, you call your Bayesian average method. You got to be more specific. I don't really know what you're asking beyond that. You just call your Bayesian average method. There's a clip where I tell you, yeah, and I basically just did that today too. And I don't mind giving hints on LT4 because honestly LT4 is a little more difficult than I wanted it to be. Yeah. Yeah, if you do LT3 with recursion, if you need practice, if you're struggling with LT4 and you didn't do LT3 with recursion, I mean, you're asking for that. Because if LT4 is the first recursive method you ever write in your life, like that's not a good first one to write. LT3 is meant to be the first one. LT4 is meant to be the second. AO1 is meant to be the third. That's the progression that I built into the course. So if you cheese LT3 without recursion, you're jumping right into a medium difficulty recursion. and you just can't do that. Recursion's too tough for you to just jump in like that. Realistically, I should have a few more recursive methods that you have to write before LT4. You filled out the contribution form yesterday? Are you sure? Thought I had my email notifications set up on that one. Checkpoint. Projects, project contribution form. Oh yeah, one response. Your form project, no, that's project checkpoint. Where's my form? Where's my email for that? I'll have to double check that to make sure I have email notifications set on that. I thought I did, so I know exactly when the form is filled out. Yeah, I'll get you your credit. That was a nice contribution. It's fantastic. I was happy with it. And how would you find the smallest Euclidean distance? I mean, the function will return xy. Ooh, I think you got to review what Euclidean distance is. Euclidean distance should return a double. All right, we're at the... Should I even cut this one off? Yeah, let's do it. So let's cut off YouTube. Bye, YouTube.